Okay, hello everyone. Module 1, CCNA2, switching, routing, wireless essentials, basic device configuration. Right, congratulations, CCNA1 yakapera. But as usual, a level before another one is usually, it seems complicated, uchitanga, but it's actually the list of your problems. It's the same as CCNA2. I think CCNA was the list of your problems. Let's get into CCNA2. Chapter 1 is your introduction. It's probably most of the things I'm going to CCNA1. The module objective is to configure devices using security-based practices. So we're going to configure the initial settings on a switch. We're going to configure the switch ports. I think you can remember from CCNA1, chapter 2, and then my initial settings on a switch as well. So it's sort of a recap. We're going to configure switch ports, secure management. We're going to configure basic settings on a router to router between two directly connected networks using the command line interface. Verify connectivity between two networks that are directly connected to a router. Okay, that's simple. All right, configuring a switch with initial settings. So where we're going to start is with the switch boot sequence. And the reason why this is important to understand, it helps you with troubleshooting, it helps you with optimizing performance of systems. It also helps you with security. Understanding what is the switch boot sequence. And the switch boot sequence, nobody's a switch. Paunesa power, auditor on. Most of them is a power and auditor on. There's a process inoitika paswitch from that point kusvika kuterminal kwako wakuona user exec mode. That process inonzi switch boot sequence, right? And it can be summarized in 5 steps, right? Step number 1, tinoiti post, POST, power on self test. So basically, this is a process where your device performs a hardware check. It verifies that my components ASA are they functioning properly. So from the CPU, from the RAM, DRAM, dynamic RAM, from the flash memory, is everything functioning properly? That's the first step. Power on self-test. Then from there, we have step number 2, which we call the ROM monitor. Step number 2, next, the switch loads the bootloader software. It's also called the ROM monitor. Let me see. Where can I find my pen here? ROM. Draw. Okay, this. Let me use this one. We also call this ROM monitor. ROM monitor is a software, same name, the bootloader software, this one. I think different literatures, but it's the same thing. So step number 2, we have the ROM, the bootloader software, which is a program which is stored in the read-only memory, the ROM, and it is responsible for loading the operating system. So the ROM monitor at this stage, step number 2, after checking all the files during post, the ROM monitor loads the operating system. Step number 3, we have what we call configuration registers. All right, this is step number 3. So let's call this config registers. To understand much better how this boot sequence works, I think it's very important to understand my type sema memories at now in my devices, my Cisco devices. Right. I think we have yet not a flash memory. Then we have ROM, I know we have NVRAM. What else? There is one missing here. ROM, NVRAM, flash. There is one missing. I'm not so sure which one. You need to understand those type of memories. Anoshanda papi. For example, software your ROM monitoring. Your ROM monitor is in the read-only memory. Our bootloader software. Right. From there, we go to the config register where we have the bootloader software checking the configuration register, which is just a memory. Memories, my devices, and my registers at some point. So it's just a memory where there is information into how is the switch supposed to boot. The switch really different types of booting. So for step number 3 up, we have the ROM monitor, the bootloader software, going to that register, trying to find information about how the switch will boot. And this is where it will find the operating system image, the image of the operating system. Step number 3, the bootloader performs low-level CPU initialization. It initializes the CPU registers, which control the physical memory, which control where the physical memory is mapped, the quantity of memory, and its speed. Basically, what is happening here, the bootloader is going to find how the switch is going to boot. From there, step number 4, we have the bootloader initializing the flash file system on the system board. Mo flash file system, do mnenge operating system. That's where the operating system will load and the image will load. Right. From there, we have the configuration file load. But not ours, but I tell us startup configuration. Startup configuration. Let me see. Up and up at one up. Startup config. Tikataura running config. Yeah. Let me see. Right. Running config. Let me do this. All right. Are you still able to see my screen?
Yes, sir.
All right. So when we were talking about CCNA1, we were talking about startup config, running config. And we said startup config is a file relocated in the NVRAM. When switch on your device, your switch, your router, your system goes and pick up that file. Ndoma settings anobuda currently. Anobuda pauno switch on your device. Then we have the running configurations. My systems that are currently running on your device can already on. My commands are kuisa ese anenge achienda munonzi mu running config file rinenge rine mu RAM, which is volatile. Right. You are true to start up you. After step number 5. After step number 5, operating system ya loadwa ndo paneno locate in the flash system, in the flash memory, yatinoti startup configuration. Startup configuration ikalocate then switch rako rovharaita on. We have successfully switched on switch red. So my steps are up. I think it's very important is understanding my types in my memories. Why can't I remove this? Okay. It's understanding my types in my memories. We have the flash, we have the ROM, we have the NVRAM. Let me see. Let me try to find the other one. I think there should be four or five. Just a minute. Okay. Okay, NVRAM, flash, RAM. Okay, I was missing the RAM. Yeah, but what is this? So these types of memories. So iOS yedu inenge muno, then bootloader redu rinenge muno. Bootloader umu ndomune startup configuration, then umu ndomune running configuration. Types memories atinenge tinawo switch. So kwatinotangira ndekunoko. Bootloader in the ROM, then we go to the operating system, the image, then we go to the startup, then we end up switching rato on up. Tinenge running configuration. So very important understanding the switch boot sequence. One, it helps you with troubleshooting. Right, suppose switch rako riri on, riri functional, then an error occurs, you also result what has happened. Switch harichato function properly, or command yaiswa, you also result zvizvaitika. It's very important understanding this boot sequence. You can sort of reset, go back at some point kumashure, recovery kumashure kwesystem, right? It helps with the recovery. So kana switch raku misbehave, understanding my steps are kuti at this point ndo pandichalodhera startup configuration, at this point ndo pane running. So it means if I want to troubleshoot, I can go back to this point startup iyo, then zvinhu zvese zvanga ndaita zviri kukanganisa switch, I can remove that. Understanding the boot sequence helps with that. Then we have optimizing of performance system. You see there are types of commands anenge ari pasystem yedu, like boot optimization. It might seem, I think most of the stuff is beyond boot optimization. Oh, yeah. Boot optimization. These are some of my settings anenge aripo pama devices edu, which might optimize the performance device here. So for example, you might remove you might move memory inenge ine startup yako, or you might move memory inenge ine operating system rako, so that you free up that space. That space can be used to optimize the device. So kana uchiziva the boot sequence, you can change some of the settings zepa boot up device yako, so that you optimize how that device works. So all that comes from understanding the boot sequence. Say, how does your device boot up? Then we also have security. There are a couple of vulnerabilities that might come from steps SI 1, 2, 3, 4. Vulnerabilities that might be exploited by attackers. And understanding boot sequence again helps you in coming up with more measures to defend against those attacks. So basically, this is the boot sequence. Let's get done with it. What you need to know, if 5 steps are host, ROM monitoring, my registers, configuration of my registers, operating system loading, configuration, file loading. Those are the 5 steps that we have. Right, from there, the boot system command. Right, the boot system command is basically, it's a command which is used, let me see, bootloader system, boot system flash. The switch attempts to automatically boot by using information in the boot environment. If this variable is not set, the switch attempts to load. Let me remove this. To load and execute the first executable file it might find. Right, the boot sequence basically tells switch rako on, and you want to tell your switch kuti ritore a boot up file somewhere in the memory. Right, in this case, boot system command rutora file mu flash memory. Right, you can see from here the storage device, flash memory, the path to the file ndiro iri rakanzi bin iri, right? This is our file rakanzi bin. This is basically the, can I say, the operating system, the image of your device. My devices edu, they run on my operating systems. And if you want to direct device rako kuti rinotora image somewhere, probably risiri the one that boot up on, you can use the boot system command. So this command, it also helps panyaya recovery as well. Switch rako waita maconfigurations ausiruziva kuti zvii zviri kuitika. You can use that boot system command and pick the image of the file. It's sort of reloading the original file repa device yako. Okay, right. Boot system command. Let's move. We have my LED indicators. So switch rako rine ratinoti my LED indicators. Anokubatsira kuziva kuti switch rako riri kufunctiona zviri proper here, or in what state is your switch operating in. Right, tina ratinoti my system LED light. You can see from diagram redu. Let me see. Change this. Right. And my LED lights are, right? You can see from the diagram. Kana mamboona switch kangoreka space kanenge kane lights kari the corner at sometimes. Right. In my lights here, they help you understanding how your switch is operating. Right. Cinema announce my system LEDs. It shows whether the system is receiving power and functioning properly. And for my system lights property 1, 2, let me see, off. Can I read off system like this? Can I read off? It means the system is off. All right, your switch is off. Then can I read green? It means your system is on and operating normally. Can I read amber? System is on, but it's not functioning properly. So we have off, green, and amber. Redundant power supply, which shows the RPS status. So when it's off, it means our RPS is off. Redundant power supply is basically a backup, right? It's backup power. If it's off, it means we don't have backup power on our device. If it's green, backup power is connected and ready. If it's blinking green, it means backup power is connected, but it's not available. Then we have amber. If it's amber, it means our backup power is in a faulty condition. Blinking amber, switch red during a problem. Our device, it has an internal power supply problem. Backup power head might be connected, but device red during an issue. So it's just important understanding. I don't think you need to claim from the top of your head with the color is not a way. But just having an idea, we have my colors up from off, green, blinking green, amber, blinking amber, and they mean something. That is very important. So you can see, for example, port duplex mode, red device yako. Can I off? It means we are operating at half duplex. We discuss my duplex mode pambera. Half duplex. Can I read green? It means we are operating at full. Port speed. Can I read off? We at 10 megabytes per second. Green. We're at 100 megabytes per second. I think another blinking green, we are now operating at 1 gigabytes per second. So my lights eye, my LEDs, they just help you in understanding how is your device functioning. So it's very important knowing could the cinema lights eye and what do they mean. All right, let's go. Okay, we have a table there summarizing, I think, basically what we're saying. And that's serial power over Ethernet as well. Okay, power over Ethernet, when it's off, it means we don't have PoE. When it's green, it's on. When it's amber, it's disabled. Blinking green, there is a fault. Then alternating green and amber, power over Ethernet is denied. Okay. So basically that's a table that summarizes, I think, everything we were saying in that previous page. Let's move. Recovering from a system crash. The bootloader provides access into the switch if the operating system cannot be used because of missing or damaged files. Right, per boot up sequence yedu, there was a step yekuti bootloader software redu ranga rikuenda nopika operating system in some specified location, more memories momwe, right? In the flash memory probably. There was a point that discussed could the bootloader software, the ROM monitor, goes and pick the operating software and run the operating software, load the operating software, operating system, I mean. What happens if there is no operating system? One, what happens if the operating system has damaged files? Does that mean switch radar chatoshandisa chose? No, there is a way to go around that. And it's summarized in 5 steps as well. 1, connect the console. 2, unplug the switch power cord. Reconnect. 3, until we have system LED flashing green. You press the mode button. Then from the switch, we have what we call the bootloader. Then kana bootloader aware here. Ndipo paunokwanisa kuisa paunokwanisa kuload an operating system from another device. Resiri your switch. So for example, you can load from, let me see, commands to format flash file system, restore the operating system, recover the lost forgotten password, for example, from the directory, right? You can load your operating system from somewhere else, but not your device. So if you have the image, is Siri for device rako, because your device pako is no longer functioning, that's where you can load it from here. You just specify the location, then you load it from there. So this is a process you could recover a system rako rengera crasher, or here if you've forgotten your password. I think from a switch enyu ever packet tracer, I've seen a couple of you vanokangana password, vaisa password by user exec. In real life, you perform process irapai, right? So that you can recover device rako. Let's go. I think next time we meet, we'll try doing this with my physical devices and see how it goes. All right, switch management access, switch visual interface. To prepare a switch for remote management, the switch must be configured with an IP address and a subnet mask. We have what we call the switch visual interface, which, let me see. All right. Right, we have what we call the switch visual interface. Switch Redu, by default, it does not have my interfaces where we can configure my IP addresses like our router. So if we want to monitor, if we want to manage our switch remotely, then it will need an IP address. It will also need a default gateway. And if we don't have an interface on the switch, we need what we call an SVI, a switch virtual interface. Virtual meaning it's not physically there. It's there, but not physically there. So from CCNA 1, you could remember command the interface VLAN 1. Then which is IP address, interface VLAN 1. This is where we were creating our switch virtual interface. This command, it created our switch virtual interface. After that, trace IP address. If we add the default gateway, basically, we can manage our switch remotely using those. Then if you can add probably my commands here SSH, then the puzzle is complete. So I think we have time to just to configure SSH as well. Then slide. Let's continue. Switch visual interface 1, configure the management interface. That's our interface VLAN 1. We configure the default gateway 2. We verify configurations 3. Right. I need to highlight verifying configurations. This one is very important. Let's do this. Keep discard. Understanding my show commands, it is very important. So when you are doing my configurations, when you are practicing, always learn how to understand as well the information. It will verb a command in the show command. Starting with command in the show run. Running configurations, show running configurations. What is the information in Ingeri paper? Patakaita CCNA1. Just a minute, let me move this to this point. Right, Patakaita CCNA1. Our show running configuration showed us kutita configure host name. Taisa banner, taisa my passwords. It showed us everything like that. We also have my commands like the show interfaces. It shows what are the configurations the my interfaces in. We also have IP interface brief showing us what are the IP addresses that is per device read. Right. Let's briefly go through my configurations at RIPAP. Starting with ASVI. We are going to have running out of time. Okay. Let me see terminal. Okay. Right. The is switch visual interface here so that we'll be able to then verify my configurations here after this SSH, and probably that will complete session redundancy. Right. Our switch visual interface shares some interface VLAN 1. Then we have our IP address 192.168.10.2. This is what I'm going to be using. Right. So IP address here, switch visual interface here. Let me see. Okay, there is one here popping up. No, it's for the network. So let me use 172.17.19.2. Then I'm going to use 172.17.19.5 for my PC / what's the network? Let's just use /24, no problem. /24. Those are the IP addresses that we're going to be using. 172.17.19.2. Okay. All right, 172.17.19.2. 255.255.255.0. After that, make it a habit description. I'll just say this is our switch visual interface. Then we activate our link. Right. Then there's a default gateway. Okay, there is no need to use a default gateway at this point. It's not router. So from there, there's some my commands here to show what is our current configuration. So we have show IP interface brief, show IPv6 interface brief. I'm not going to be using IPv6 because I don't have any IPv6 configurations than ISA. But I can show running configurations. Or towards a switch, or let me do this so that it makes more sense with what we are currently doing. Right, let us add the router there. Okay. So with our router, let's have the interface. Thank you very much. Whilst we're there, iyo ndo inonzi booter process iyo. Mahasha anga muri kuona pascreen ayo. That is the booter process yanga iri kutoitika on our device. Take note of that. Pamuna drag router muchiisa pa screen next time. All right. Interface gig 0, 0, 0. All right, IP address 172.168.19.1. How much time do we have? 6 minutes. 255.255.0. That's my IP address. Let me confirm. 172.17.19. 172.17.19. Okay, it's correct. Making it a habit. Description always. Description link to, let's just say LAN. A link to LAN. Then we have IPv6. IPv6 address. What is the IPv6 address? Can I copy that one? Let me see. Okay, there it is. IPv6 address 2001 DB8 ACAD 299 121/64. Okay, that's our IPv6 address. The server address here. IPv6 address. Okay. No shot. Activate our link. Right. Then ndochiisa commands atationa show commands. Show IP interface brief. Very important. Understanding commands iwayo. Show IP interface brief. Right. So from this command, I can see interface ready Giga Ethernet 000 that's an IP address, and my link is currently up 172.17.19.1. Right. Ndikaisa show IP v6 interface brief. I can also see, all right, this is my IP address under configure on my gig Ethernet. I can also see the link local address automatically generated and now by interface, but it's there. So if you can go back to IPv6 knowledge yedu, we have link local address inokwanisa kuitwa automatically generated on an interface, and that is what we have, our show commands in action. Right, per switch redu, I can also have show run. Let me skip console. I'm used to this one. All right, there's a show running configurations per switch redu. I can also highlight pana kuti switch redu rapiwa a switch visual interface and the IP address is there. I can verify that as well. But I'm just gonna default gateway here. Let's put our default gateway. IP default gateway 172.17.19.1. Our default gateway in this case, key default gateway, very important understanding. Default gateway right from this point, default gateway is network is interface here, router here, it leads to this network, and everything in that network, it uses this point here is its default gateway. So default gateway redu is 172.17.19.1. Make it a habit. Every device iri munetwork inofana kuiswa default gateway. Otherwise, it will not be able to communicate remotely. If you try to connect locally with other devices and communicate, it will communicate locally, but remotely, it will not. So it's very important understanding the importance of default gateway. All right, so let's just enter default gateway yedu yapo. Let's verify. Show run. Voila. And there we have our switch visual interface and our default gateway. It means the connection kedu kekalanaka is now functional. So let's just test. No, let's not test. Let's test after. Let's continue with this slide. We'll be coming back to this network and purchase a switch visual interface here. I think a couple of more commands zirikutera according to slide that. Right. Switch visual interface done. All right, I've paused recording because I have less than 1 minute left here. So this is going to end. Use the same link to join. I think we're continuing in 3 minutes. 21:49. 21:50. Make it 21:50. We continue to pay the session. So join, use the same link.